So good afternoon, all participants on site and online. Welcome to the 4th RISUD TOAF Distinguished Lecture organized by Research Institute for Sustainable Urban Development and sponsored by the OVRUP Foundation. So the speaker of today's lecture is Professor Kebin He from Tsinghua University. Professor He is the Dean of Institute for Carbon Neutrality at Tsinghua University. He is also a member of Chinese Academy of Engineering. The topic of today's He's lecture is Synergy Pathway to Carbon Neutrality and Clean Air in China. Before he starts, may I now invite the president of PolyU, Professor Jingguang Teng, to give us a welcome speech. Professor Teng, please.
Dear guests, good afternoon. First of all, let me welcome all of you to join this event on behalf of the university. Now, the reason I came to this event was because many years ago I was the director of this Research Institute for Sustainable Urban Development. So this lecture series was started then. I remember that we had a advisory committee which was chaired by Dr. Andrew Chen, who was, I'm not sure whether he still is. He was the chairman of the OVRUP Foundation, trustees. And so he was very kind to secure a donation for us to support some scholarly activities for the Research Institute. And a part of that was this OVRUP Foundation Distinguished Lecture. So this is the 4th one. I thought we should have done more than this, but anyway, so over the last 2 years, I guess because of the pandemic, we may not have been able to do this. So I'm pleased that today we are able to, do this again, although, the Omicron has just come, and therefore, I guess we only have a small audience face to face, but I'm aware that there are many more people online. The topic that Professor He is going to speak on is certainly very important to us. It is also a great opportunity to Hong Kong, because Hong Kong's target to achieve carbon neutrality is 2050. Our national target is 2060, and therefore we have to achieve our target 10 years before the national timeline. And I would imagine that the Greater Bay Area would like to achieve this target a little earlier than the national target, because the Greater Bay Area is more advanced than other parts of China. So I think there is an opportunity here for Hong Kong's researchers, Hong Kong's technologies to play an important role in helping the Greater Bay Area. And first of all, of course, in achieving our own target. So I look forward to listening to the lecture and benefit from the wisdom of Professor He. And let me also thank Professor He for finding the time to speak to us. I guess that's all I want to say, and I wish you a fruitful and also enjoyable lecture. Okay, thank you so much.
So thank you, Professor Teng. Now may I invite chairman of today's event, Dr. Vincent Zhang, RISUD fellow, to speak a few words to us. Dr. Zhang, please.
Okay, Professor Tang, Professor He, and Professor Wang, and ladies and gentlemen, good afternoon. I'm indeed very honored, today to chair this event, which is the 4th our distinguished lectures. For many of you may know that the OVRUP Foundations, or the TOAF in short, is an educational foundation set up to commemorate our founder. So OVRUP, its purpose is to promote multi-disciplinary approach to designs for the built environments, which is what we call total architecture or design. Sustainability is center to this purpose because of our Sir Alvarez's kind of care and also concern for the environment. The foundations sponsors and also collaborate with numerous universities around the world in research and also activities promoting the aims of the foundations, such as meetings that we conduct with the University of Hong Kong and the Sustainability Leadership Master Degree programs. We collaborate with Cambridge University and also one of the most famous kind of city program. We work with London School of Economics and Political Science. So in 2016, that the foundation actually make a grant to PolyU's Research Institutes for Sustainable Urban Developments for 4 years programs for hosting distinguished lectures and summer school for students from Asia on topics to do with the various disciplines working together for sustainable urban developments. As we know that this is the fourth distinguished lectures in the series, and we are pleased to have Professor He today here from Tsinghua University to share his expertise on carbon reductions and air pollutions, and more importantly, on his insights on achieving the new commitments, what Professor Teng just mentioned on the carbon emissions in China. I think this net zero kind of commitments made by both our mainland central government and also Hong Kong SAR governments carry immense, I would say, importance on the sustainable developments for our country and also our city in Hong Kong. Indeed, also have a kind of effects on this region as well as the rest of the world, given the sheer size of the economies of China and also the amount of the emissions itself. So today's this event will provide good opportunities for Hong Kong and also other cities to learn the latest thinkings and also the policy in mainland China, and through this platform, these digital platforms that we can share around the world on the know-how, how we can work together to deal with this global problems. And finally, on behalf of our foundations that wish this event every success, and more importantly, that look forward to more collaboration with RISUD and also with PolyU in the near futures. Thank you.
Thank you, Dr. Zhang. So we also would like to thank OVR Foundation's general support of this lecture series. So now let's give time to our speaker, Professor He, please.
Okay, thank you, everybody. Good afternoon. Let me share screen first. Okay, is the screen okay? Yeah, so it's my honor to be here to give this lectures. The title of this lecture is Synergy Pathway to Carbon Neutrality and Clean Air in Mainland China. So I will talk about 3 points. The first one is progresses, and second is perspectives, and the third one is constraints. So if we want to realize our goal for both clean air and the carbon neutral. So first is the progresses. So as we all know, the central government just issued a very important action plan. We call it the Air Pollution Prevention and Control Action Plan in the year 2013. So after that, we have almost 9 years efforts to improve the air quality, especially the PM 2.5 concentration. So the first, we have to do a lot of scientific supporting, especially for the we call it the new advanced monitoring and observation system. So that including not only the ground the monitoring and also the airplane monitoring system, and even we have the information from the satellites. So that is a very strong to getting, how the air emission and air pollutants changes in different area and different time. And second, we have to understand where is the emission comes from. So we have developed a national facility level industrial emission database. It's including more than 100,000 point sources, like say industrial of coal-fired, iron and steel, coal-fired power plants, and iron and steel industrial, and building material like say cements, and even all of the industrial boilers for both CO2 emission and air pollutants. And also for the transportation system is another important issue for the emissions. So we have established high resolution mapping of the road transportation emissions. So they have getting every, the emission factor and the county level emission, and also the county level activities. So as we all know, there is several thousand counties for in the mainland China. So we have collected the details of all of the car ownership, and also the detailed information for the transport, the flow rate. And another point, another area, the third area is importance is residential emission that we have estimates based on the survey data in city, especially even including the rural area for the crop, ridiculous, and wooden, briquetting, and raw coal. So they have the detail. So after your understanding the emissions and also the observation and monitoring, and you can relatively easily understanding which parts is the important emission reduction potential. So, and then we can doing the action plan. So actually for the last 9 years, we almost doing a series of the reduction measures, including ultra low emission retrofits for coal-fired power plants, in-depth governance of the non-powered industrial and VOC control, and the clean heating and rural area, and also the mobile source emission control, and so on. So they have doing huge work for that. So for example, we have after this action plan, we have a much better, significant progress in the energy transition. So in the intensity of energy consumption continuous decline. In 2020, energy consumption per unit GDP reduced by more than 13% compared to 2005 level. Especially for coal consumption decreased from 63.8% to 56.8% during the year 2015 to 2020. So I think that is huge. And on the other hand, the proportion of natural gas, hydropower, nuclear, wind, solar, and other clean energy consumption in primary energy is increased from almost 18% 2015 to about 24%, more than 24% in the year 2020. Another point is a significantly optimized industrial structure. So we have, you can see the industrial generation is increased all the time in the install, including the installed power capacity, the steel production and cement production. But on the other hand, the ratio of the primary, secondary, and tertiary industrial is improved all the time. So they have we have doing important three aspects including new industrial and new business model as a grow rapidly. And the second is a clean air initiative has accelerated the elimination of the backwards production capacity. And also we have phasing out the poorly managed and pollutants small enterprise. So they have a big change. The industrial structure become much better than before. And also for the transportation sector, so you can see in terms of the transportation restructuring, by the year 2020, the total volume of the good transport by rail reached 4.6 billion tons, and also the total volume of the good transportation transport by waterway reached 8 billion tons. So that is which means they have a much better the lower emission compared to the road transportation. So another point is that by the end of 2020, a number of the new energy vehicle in China has reaching 3.39 million, and the mileage of the high-speed railway reached 38,000 kilometers. So it covers nearly 95% of the cities with a population of the over more than 1 million, over 1 million. So there is all of the others. I don't want to go details of all of the information. So this transportation structure is getting also much better. So from all of these control measures, we have getting the upward trends of China, mainland China's major air pollution emission is gradually being curbed. So you can see here we have reached, after 2005, the CO2 SO2 emission is going down all the time, and the NOx has going down after 2012. And also the other pollutants is going down, even for the with the national GDP increase all the time. So I think it's getting like the carbon, the emission peak of SO2 NOx and primary PM 2.5 has reached the year 2016, 2012, and 2006. So respectively. So when you have a huge emission reduction on the grounds, you will get a much better clean air in the air. So you can see the PM 2.5 concentration has been improved after 2013. So this is a different area of China, like the Beijing, Tianjin, and the Hebei area is going down. And Yangtze River Delta and the Polar River Delta is going down all the time. So I think that now more and more people has feeling the much better air quality in Eastern China, especially. So on the other hand, we're also getting the growth rates of the anthropogenic CO2 emission has slowed down significantly. So you can see the average annual growth rates of emissions from 2013 to 2020 is about 1%. But compared to the much lower, which is much lower than the almost the 10% growth rate of the emissions from the year 2002 to 2013. So the recent 10 years is only 1%, but last decade is almost 10%. So it's a huge, which is a huge reduction for the CO2 growth rate. And also we have getting a little bit detailed analysis for the synergistic emission reduction of CO2 and air pollutants. So we can see here is a difference in the power, heating, industrial, this residential and transportation. for both CO2 and conventional air pollutant. So you can see for the industrial, we have getting both conventional air pollutants getting down and also CO2. But in the power sector, it's only we have a huge reduction of the conventional pollutants, but the CO2 is still increased because we have a still higher proportion of the coal burning power plants. So that is I think it's an important progress already, and we can see how. So last year, the central governments, the President Xi Jinping has announced, China will reach the carbon peak year 2030 and also the carbon neutrality for 2016. So what happened if you have in the future? What is a better pathway in the future? So actually, for the future pathway for CO2 reduction and air pollution mitigation. So first, for the CO2, when you comes from today and to 2016, when you reach the carbon neutral here, so from how can we get the carbon reduction within next 14 years? So I think we can divide it into 6 aspects. The first one is a carbon reduction by resource utilization. So which means like the cycling economy, energy saving. So the second, that is the largest part, is carbon reduction by adjusting energy structure. So we were increasing the non-fossil fuel power, like the energy, like the wind power and solar power will become the majority in the future. And the third one is the decarbonization of the industrial process. And the fourth one is carbon, the CCUS. And also we have the ecosystem, the carbon sequestration, which means the carbon sink. But not only those technology options, we still need, because that is a larger action plan for almost 14 years. So the carbon reduction by using the marketing mechanism is very important. As we know, last year, the July 16, 2021, mainland China has initiated the carbon market in Shanghai already. So that is a better, the basic options for that. How can we get in the quantified analytical, say if we go pathway like that and different scenarios, how can we get the results? What kind of the reduction for carbon emission and also the clean air? So we have established, I mean, the Tsinghua University has established a new platform. We call it carbon neutrality and the clean air assessing platform. So some of the model is our self-dependence model, and some of them we have used in the international model. So getting scenario design, emission, air pollution, and cost benefits. So let me get a little bit details about that. First is a MAKE model, that is a multi-resolution emission inventory. So that is maintained by Tsinghua University. Is established a high resolution anthropogenic air pollution and carbon dioxide emission inventory. So it's has been provides the emission data to scientific community, which benefits the scientific research. Now we have more than 500 users in the world for this major air pollutants, and this database we have provides the major air pollutants and the CO2 emission in mainland China the year for the last 30 years. And here is just an example. We can provide the 3 kilometers resolution air pollutant emissions. Here is just example of SO2 emission. And also we have the graded CO2 emission with a 1 kilometer resolution. The time frame is from 2012 to 2019. And the second, we have, for the future projection, we have established a dynamic projection model for emission in mainland China. We call it a DPEC modeling. So we have two modules for that. The first one, we have the version 1.0. We have doing that for the year 2015 to 2015. So we have designed the pathway for that. And also recently, we just finished the version 1.1 because last year, the China just announced the carbon neutrality to the year 2016. So we have extended to 2016 for the carbon neutrality and carbon peak and carbon neutrality targets. So we have this model can design that. And the third one, we call it tracking air pollution in mainland China, which is the database driven by the machine learning approach that combines the information from multiple data sources, including ground measurements, satellite retrievals, emission imagery, and chemical transport model simulation, and meteorological fields and land use data. So that is a huge the database and also the platform. They can provide different kind of products. Here is just an example for the nearly real-time concentration of PM2.5 and ozone. For PM2.5, we have data since 2000, the year 2000. And for ozone, we have 10 kilometer resolution since 2013. So that is very useful for the simulation and from the PM2.5 temporal and the spatial evaluation from 2000 to 2020, so the last 20 years. So you can see the PM2.5 concentration is increased for the first 2013, and it's decreased all the time. So it's getting much better from this database. So you can show that. And also we can doing the future projection, energy transition. So from 2015 to 2016 under the carbon peak and the carbon neutrality goal. So we have including 4 aspects: power generation structure, industrial, final energy structure, and residential and transportation sector. And we have 5 scenarios, which including 1.5 degree carbon neutrality, 2 degree, and the NDC and the reference. So we have, so you can see the difference. They have the huge changes if you have a different the scenarios for the energy structure, which means the higher proportion of the non-fossil fuel will be used in the future if we're trying to meet the target of the carbon neutrality, especially for 1.5 degree scenarios. So if we realize the goal of the carbon peak and the carbon neutrality, what happens for the conventional air pollutants? So I think for the SO2, NOx, and PM2.5, there is a huge benefits through the carbon, the reduction pathway, and we can get a huge potential for the conventional pollutants, the reduction, the emission reduction. So which means if we do not have the carbon peak and carbon neutrality program, we can just improve our air quality by the year 2020 for the next 10 years. After that, the emission reduction potential is become very small. But we have, if you're following the carbon peak and carbon neutrality pathway, we still have the failure reduction by for the NOx, say 67% and even 83% for SO2 reduction for the from the year 2013 to 2016. So that is a huge benefits from the carbon reduction for the conventional air pollutants. So how about the air concentration? So we can see if we really go the pathway of the carbon neutrality until the 2016, the average PM 2.5 will meet the less than 10 microgram per cubic meter by the year 2016 for the whole the average level concentration for the whole nation. So that is a really very exciting results for us. But the majority efforts will come from the energy transition. So that also is a long-term for the long-term improvements of the air quality. So which means the more than 55% the air quality improvements comes from the energy transition. So that the energy sector is a very key sectors for the future. So here we have just shown the synergistic pathway for the carbon peak and also the clean air and the carbon neutrality and clean air targets. So which means if we have without the carbon peak and carbon neutrality, we only can reduce improve the PM 2.5 until 2016. So the PM 2.5 concentration is 25. But if we have the carbon peak, this number could be the 20 or 18 to 20. But if you have a carbon neutrality pathway, and this number could be less than 10. So that is a huge health benefits for our people. So, and how about ozone? So I think they also has a huge improved. This is if you are following the carbon peak and carbon neutrality pathway, and we have the year 2013, the ozone concentration almost meets the national standards, and also they have much better in the future if you're following the carbon neutrality. So ozone is not the problem in the year 2016 if you follow the carbon neutrality pathway. So I think that is really a very important, the very good results if you have the driving force from carbon peak and the carbon neutrality for the air quality improvements. So the third one is it's not easy to, there is a constraints. It's not easy to meet the carbon peak, especially the carbon neutrality, because I have just mentioned there are huge efforts we'll be doing for the new energy system, which means that the non-fossil fuel. Here, this is from the International Energy Agency. They have doing the worldwide the scenarios in the future. So you can see wind power and solar power, hydro and also the bioenergy will play a very important role in the future energy system if you want to meet the carbon neutrality targets. So which means in the future, solar power and wind power has a huge increase in potential for the national worldwide. So which means the in the worldwide, the solar PV and wind power need to scale up rapidly to decarbonize electricity. the estimation is a total solar PV capacity will grow 20-fold, and wind power is 11-fold by the year 2050. So that is really huge. But the key area, the key periods could be the recent 10 years. So from now to 2030, there is a huge potential for the capacity of the wind power and solar power, and also the electric car. I mean, that is the worldwide and the estimation. And for the energy intensity of the GDP was going down 4% per year. So how about the mainland China? So I think from the modeling, the National Climate Research Center, they have gotten the estimation by the end of 2015, the ratio of the non-fossil energy in total energy of mainland China will meet over 5%, and the ratio of the non-fossil electricity in total electricity will be over 19%. So the capacity of wind and the solar power could be more than 6,000 gigawatts, which is 11 times of the installed capacity in last year. So this is a huge increase in the future. So we have doing some of the modeling analytic work for the solar PV potentials, trying to find the technical feasibility, economy parity, and the grid compatible. So here is some of the results. We have doing the multi-time scale, including hour, day, months, and year for solar PV for potential and regional distribution. So we can get, annual technology potential could be reached almost 100 watt hour in the year 2020. That is 3 times of the electricity demand in the same year. So the potential is here, is huge. But the power generation potential of the northwest, northern China, and northeast power grids exists their representative power needs by more than 12 times. But the Eastern China, this area has sufficient potential for the solar power. So that is the majority, the area is here, but they have some problem in this area. And also we have during the areas we found of the high-risk capacity factors are concentrated in Qinghai, Tibet, and Gansu, and Ningxia, and Inner Mongolia, so that area. But the southeast region has the low-risk capacity factor in the country. Xinjiang, Inner Mongolia, Tibet, and Qinghai, and Gansu account for more than 85% of the country's installed capacity. So the majority is in the northern and east, the west, the area. So we're also getting, if you can, the estimation in the year 2021, 78% of the technical potential has reached the grid parity compared with the local coal power. So which means the price is nearly low, less than the local coal power, and the national parity grades is expanded to the year realized by next 2 years. So I think that is really very exciting. But for the long term, it's still will be decrease for the price of the solar power. We think it's in the year 2013 could be only 0.09 yuan, so it's a 9 cents for kilowatt hour. By the year 2016, only 3 cents of Chinese yuan for kilowatt hour, each kilowatt hour. So that is the very important pathway for the solar But how about the worldwide? We have just published one journal paper in Nature Communication to getting the temporal variability of solar and wind power, and you can see we have analyzed the 93 countries, including China, Germany, US, South Africa, Brazil, and Australia. So we can find in different 24 hours in daytime and nighttime, winter and summer. So they have some of the spatial and temporal mismatches between source availability and electricity demands. So that is for this future system reliability, that is really challenging. So they have two choices to increase the reliability. One is trying to increase, the generation 15% high, more, and also you have a choice of the storage, the energy storage, electricity storage. So this is a non-storage, 3-hour storage, average 12-hour storage. So with this increase of the storage capacity and also the generation capacity, the reliability will be increased gradually. So that is the second point. And the third one is that is interesting finding. So that there is, the global wide, we can see some of the country. If you're thinking about that country by country, the country with a large area have the better reliability for wind power and solar power. But for the small ones, they have really risk for reliability for this two kind of power in the future. So for example, China, US, Russia, and European Union, it's not a problem. But the country like South Korea and even UK, some of the years, 2,000 hours problem for the power supply if you have the high proportion of the wind power and the solar power. So which means we have to help each other. So in the future, maybe we should design the electricity system is a multinational, continental, or even intercontinental connection. So if you they can help each other in different nations. So finally, I just have the conclusion here. We should fully consider the synergistic effect of different technology pathway on air pollution emission reduction. Second, we should promote the improvements of air quality as an important constraint for the choice of carbon neutrality technology pathway. Especially, this is really especially for developing country because they still have a lot of environmental problems, including air quality, like China, India, the Brazil, so on. The third one is trying to maximize the synergistic effects of reducing pollution and carbon emission. And finally, we should thinking about the specific multinational, continental, and intercontinental connection could be very important for the reliability of the new energy system. So I think I stop here. It's very happy we'll have a discussion and Q&A. Thank you.
Thank you, Professor He. Thank you very much for your very informative and thorough analysis of the data. So before we start our discussion, so we needed, let's take a 2 minutes break. So because we have some settings to figure out now. So Professor He and Dr. Vincent, please stay online. We will come back very soon.
Thank you.
Thanks.
So, hello everyone. We will start our discussion now. So, may I now introduce the members for discussion of the discussion panel to you all. The chairman of the panel is Dr. Vincent Zheng online. So, Vincent Zheng is our fellow. And for the members, we have Ms. Harry Lai. Ms. Lai is the principal advisor in carbon neutrality of electrical and mechanical services department, Hong Kong SAR. And then we have Mr. Zheng Haowei Albert. So he is the chairman of the Hong Kong Green Building Council. And we also have Chair Professor Tao Wang, Chair Professor of Atmospheric Environment in PolyU. And me, I'm Linda Xiao. I'm a professor and associate dean of Faculty of Construction and Environment, PolyU. So, okay, let's start discussion. Chairman, so please.
Thanks, Linda. Thanks in particular, Professor, for your very informative and I think more important your insights on how we can arrive at I think two very important kind of objective of one achieving that carbon neutrality and also on the air quality controls. So I'd like to start with the questions from you. Where basically, you give us a very kind of good roadmap. I think more importantly, the kind of measures that how we can arrive at that end. Can you give us more kind of details on how in policy, in technologies, or in other kind of vehicles that we can approach that sectorial changes? But in particular, you mentioned that energy, buildings, and also transportations is very important when arriving at zero carbon or carbon neutrality ends. So, can you enlighten us with more details on how China, as a country, can move gradually on that end? Professor He?
Yes. Can you hear me?
Yes, please.
Okay. Thank you for your question. I think actually the key point is the energy transition in the future. The majority issue is how can we make full use of the solar and wind power. So that is the key question. But the important part is a new electric grid system, the new system, which can get the connection from the supply chain, wind power and the solar power. The big changes is the renewability changes. If you rely on the coal burning, and it's relatively easy for the renewability, but in the future that is a big problem. So we have to design the integration of this system, which means you should have the much better projection, like the weather forecast. But in the future, it's not the weather forecast, it's the resource forecast for solar and wind power. And if you have that kind of information, and then you need the new electric price system. So they have to change all the time. And then this thing will have some impacts on the demand sides. So the storage of the electricity is important, but it's difficult to have a larger scale central storage system. So we have to design in the future, trying to make full use of the electrical car. So the current population in China is like the mainland China is like the 6 million electric vehicle right now. But after 5 years, this number could be 20 million. And year 2013, this number could be 8 million. 2014 could be 200 or 300 million. So in that case, if we have designed the new system, the people can recharge their electric car, pay money, but they also can supply electricity to earn money. This is two-way the system for the charging system. So now we have they have some new business. We call it a virtual power plants system. So that that will be a very challenge. So that is the non-way for the future, great step by step. But there is a lot of technology and scientific working. The question still need to answer. So the IEA just has established their conclusion is that globally, almost half of the technology is in the markets, but another half is still in the R&D. This number could be 14% in mainland China, 40% is in markets already, but the other 16% is still on the way of R&D. So that is a real challenge for the research institutes, including the university professors and also our next generation of the students. Thank you.
Thanks, Professor. I'd like to come back be more focused on the issues in Hong Kong. Here we have a panel of experts who know the issues in Hong Kong well. In particular, that chairman of Green Building Council, who actually Zhang Hawai, Mr. Zhang actually have been working in this area for many years. So, Mr. Zhang, from your perspective, what do you think our building sector, can do? I think more. I mean, in particular, giving that building actually account for over 60% of carbon emissions. So, in the context of Hong Kong, what do you think the industry or what Professor suggests the kind of collaboration that needs to be in place to help on that?
Winston, thank you for the question. In Hong Kong, we are in a high density, high-rise city scenario. The scenario is common, in fact, to many built-up cities in the mainland and in other parts of the world. I think in order to we need to maximize the production of renewable energy in buildings, as well as to minimize the use of green fossil fuel energy in buildings. There are a number of ways I think we should explore. The first is we should explore how we can make the best use of the envelope of our building. As we all know, most of our modern buildings heavily use, extensively use glass on our external walls. So there is the opportunity for us to make the best use of these glass walls, curtain walls, for maximizing the generation of solar power electricity, as well as to minimize the penetration of heat to inside our buildings, in particular in tropical area. The other measure I think we need to examine is how we can make the best use of our common areas in buildings. In terms of common area, I mean our main roof, our podium roof. We may have different sky gardens up in our buildings, as well as our ground floor areas. The object is to see how we can use these common areas for both recreation, greening, as well as for renewable energy generation. The third area is that we should design our buildings for adaptability to see how we can allow for the use of different types of users of buildings and installation of new technology in our buildings throughout its long life cycle. We should also expand, make the best use of building material which use less energy for manufacturing. And there are also opportunities beyond our buildings. We should look at the whole built environment outside of our buildings to see how we can make the best use of natural light, wind, water outside our buildings to facilitate the generation of natural ventilation, renewable energy in our buildings, as well as to facilities outside our buildings in the whole built environment. I think we should also examine how we should be able to synergize the use of electricity. Professor He has mentioned the need to see how we could better store our electricity, and also we should see how we can modulate the use of our electricity to meet peak and trough demands in different types of building use. So I think a lot we can do to improve maximizing renewable energy generation and minimize use of electricity in our buildings.
Thanks, Mr. Zhang. And I think I'd like to turn to an area which Professor He has mentioned about the demand side control. That actually can help to reduce a lot on the kind of efforts that we should put on the supply side. So on that area, I'd like to hear from policy or regulatory control perspective how these kind of things is happening in Hong Kong. I know that Mr. Lai, Harry Lai, is senior officials here in Hong Kong in charge of this energy efficiency. So from your perspective, what do you think will or should form the kind of policy or regulations that can help us to reduce or improve the energy efficiency in different sectors?
Thank you, Vincent, for the question. As far as demand side control is concerned in Hong Kong, we have a long history since our energy efficiency office has been formed over 30 years, and we have been relying on several tools. And we firstly on building, we rely on the building energy code, and then through the building energy efficiency ordinance. And second is on about electrical appliances. We work through the energy labeling system, and then of course we have government is also taking the lead to set energy saving targets, and then we work partnership with the private sector. We have in the past we have the 40 partners. The 40 stand for it's promoted by the Environment Bureau, and now we convert this partner into our carbon neutrality partners. We work together to achieve carbon neutrality. One of the major contribution, of course, is demand side management. And so those are the regulatory tools as well as the initiative we introduced. But apart from demand side management, I think I would like to take this opportunity also to talk about this renewable energy contribution in Hong Kong. As far as Hong Kong is concerned, because 2/3 of our carbon emission is related to the energy sector, and that's why our energy sector's contribution to carbon neutrality is very important. And of course, we will try our best to introduce as many as much as possible to improve our renewable energy contribution. Now we already set the target trying to achieve 7.5 to 10%, up to 10% of our renewable energy contribution, and with the eventual target probably reaching to 15%. But still, there's only a small portion of the total energy consumption. But I would like to, of course, in Hong Kong, our potential is also, as since Professor He mentioned, is solar power, wind power, and also we have another sector is waste energy. These are the three main areas of contribution to our renewable energy. But I also noticed from Professor He's presentation is about the distribution of renewable energy in the mainland China. I noticed that because the renewable energy potential is very different in different parts of the mainland China. I noticed that the potential is high on the northwestern part as well as the northern part, but the low center is on the eastern part. So I think this is a very interesting scenario. I think in the past, we all know that in China, they already have implemented this 西电东送 for a long period of time, the transporting the electricity from the western province to the eastern provinces. So renewable energy, I think, is also this. I presume it will be similar in future. How we transport the renewable energy from the renewable energy rich provinces to the renewable energy less rich provinces, like on the eastern side, eastern coast of mainland China. And in fact, Hong Kong is also on the eastern coast, and Hong Kong is also a place where complexity is not possible to develop a large amount of renewable energy. So maybe we have to rely on such a time of transportation of renewable energy, how to transport renewable energy available from the renewable energy rich provinces to the renewable energy less rich provinces like Hong Kong on the eastern coast of China. I think it's a problem that we need to face. And I also want to learn from Professor He how the mainland is handling this issue.
Before we get to that regional collaboration, that let me finish another kind of area is also important mentioned by Professor He is on the R&D. I mean, in that areas, I think the university play a very important role on developing either technologies or helping to create kind of platform to exchange or to discuss a kind of solution on that. So on that end, I'd like to ask Professor Wang, and from the perspective of university, in particular, Polytechnic University, how you could help, to put us, ahead of this peril of climate change.
Hi, Professor and Chairman, and my name is Tao Wang, and I mainly work on air pollution. So I think it's just as in the area of reducing air pollution, research is very important. So at PolyU here, we in the pollution control side, we have professors and research staff working on prediction and monitoring, and also some control of air pollutants. I think that has been proven pivotal in part of integrated solution to air pollution problem. And in the future, I think the PolyU our air quality team, and also together with other our colleagues in other departments, engineering services, I think they can definitely control, contribute to the carbon energy saving and renewable technology development. I think it's the area we should do more according to expanding our pollution research into carbon reduction efforts.
Thanks. Now I'd like to turn to Professor He. I mean, in one of your last slide, you have let us know the importance of collaborations, be it regionally or internationally. So on that area, so how do you see kind of China can help to take the lead, to coordinate? I mean, our neighbor, together to create kind of force to move ahead on this renewable or climate issues ahead.
Okay, thank you. I think first, if you want to, actually, the previous speaker also mentions how can we get in, within mainland China to balance the western and eastern, the electricity demand or supply. So, and also the internationally, as your question. So I think first, China has, I think we have a very strong technology for the long-term electricity transmission. So the Tsinghua Department of the electrical power, they have even for the national, for the worldwide, that is advanced technology. So that is a high voltage, long-term transmission. So that will be useful in the future. But for the new system, for the new power system, we have to get in the much better the resource, solar and wind power resource, high resolution for temporary and spatial forecast. So that is also important. I think that it's the forecast is not only for mainland China and also the neighbor nations. So it's a regional. And then we can design like the different grades within China. We have the eastern, northern China. So in the world, we can working together with the international team, maybe some of the organization under United Nations to design in the future, to design how can we design the future system in different areas. So for my last PowerPoint, the slides, just showing the possible, just the idea, maybe we should do some regional, but if you want to do that, you have to detail analysis and also the design. But the approach is there. We have to help each other, cooperate with each other.
So thanks. I'd like to open the question to the floor. If anyone got questions to all our panelists, by all means, you can turn on your mic and ask. Anyone have questions to Professor He or our panelists?
Hello, Chairman. Hello, Professor He. So I'm Linda. I'm a professor in the Faculty of Construction and Engineering. So just a few days ago, I read a news about the China Ministry of Education. So they call for some new undergraduate programs on carbon neutrality. So I'm quite interested in that part. So I don't know if you have this kind of initiative at Tsinghua University. And if yes, would you please share some experience with us? Thank you.
Okay, thank you for your question. I think it's a really good question. We're still discussing in the education area in mainland China. So I don't know the very detail for the whole countries and other universities, but for Tsinghua University, the moderate, when you introduce me, we have the new title. I have the new title is Dean of Institute of Carbon Neutrality in Tsinghua University. So that is not the teaching system, it's a research interdisciplinary research. So as I just mentioned, the new grid electric system is a key part. So in Tsinghua University, we have power generation departments. We have electric grid power grid departments. That is a supply side. And also the demand side is we have the architecture school. We have a school of the automation engineering or something like that. So we have to integrate both the demand and supply sides for the electricity in a new system in the future. So that is important for research, technology, and system. And secondly, for the education system, recently we are just doing some of the interdisciplinary doctor program for helping the cooperation in different departments. And also we just designed a new initiative of the classes, a serious classes, which has a closer relations with the carbon neutrality. We have designed that classes, but we do not plan to do the undergraduate students because I myself understanding carbon neutrality is this different discipline working together to meet the targets. But if you design a new discipline in the education system, we still need time to thinking what is that for the undergraduate students. So that is the case recently. Thank you.
Thanks, Professor. Before we end this panel discussions, I'd like to get from the panelists' view on just a simple sentence or words that, in your perspective, what are the kind of biggest changes you like to see, be it in policy, be it in technologies, or be it in practice in industry or in our education system or people's mindset? What do you think is the biggest kind of changes that need to be happen or in place before we can actually get there? So anyone want to answer this? Mr. Jim?
I think today we have the research universities, we have people from the government, and we have the industry. I think we all need a very close collaboration so that our fundamental research can be applied to the industry and to the community. I think we all need to collaborate in our effort for.
So collaboration is your advice, your wish. You like to see the kind of changes in the coming years. So how about Mr. Lai?
Yeah, I echo how collaboration is the important issue, because I think we all know recently we have this COP26 meeting held in Glasgow, which is a very important meeting. Followed is the most important meeting after the COP21, where they have the Paris Agreement, because it's a 5-yearly, the first 5-yearly reporting cycle. And you can see that all the countries, more than 190 countries, submitted the national determined contribution, including China. And I'm glad to see that, in fact, Hong Kong Climate Action Plan is also part of the China's submission. And I can see from this COP26 meeting, as well as the result from this meeting, that international collaboration, the regional collaboration is very, very important in achieving this carbon neutrality goal.
Definitely.
Carbon neutrality by mid-century. So collaboration is the key.
Thank you. Professor Wang, any advice from you?
I think in the long run, we really need to decrease our reliance on fossil fuel.
Yeah.
President has presented the roadmap. I think we agree that we should do this, but I think it's very challenging.
Thank you.
We can achieve all these, even we've been so dependent on fossil fuel in every aspect of life. I think it's really, we need to have the right policy and also the technologies to really push this forward. I think this is the key. Otherwise, have a good plan, and if we don't have the right,
Indeed.
I think that would be a huge challenge for us to achieve.
Action is what we are after, right? Okay, thanks. Mr. He, final words from you.
Yes, thank you. I think the largest change in the future is the visual thinking. For the carbon neutrality approach, starting the world economy pattern has a big change from source-driving economy to technology-driven economy. And maybe I could a little bit explain for that. IEA just estimates the total solar and wind power resource. The conclusion is we have enough resource for wind and solar in the world for supporting all of the world to realize the carbon neutrality. But the question is half of the technology is still on the way of R&D. So in the future, Henry Kissinger just said, if you control oil, you control a world economy. But that is not the case in the future, because the oil is limited, but the solar and wind power is enough. So the Chinese the Climate Research Center also has a similar conclusions for mainland China. Even we have the unbalance between West and Eastern, but the total wind and solar power is there. So if you control the technology first, and then you have the much better future for your economy. So that is a technology driving, is not the resource driving. That is a totally new period. Thank you.
Thanks. Our expert panels today. That I think we have very good kind of discussions, and I think it's what Professor suggests is kind of a long-term and kind of a long-standing kind of challenge that we have to face in the coming years. And I think we need to work closer and more importantly in collaborations to develop, I think, more solutions that help us to, advancing to get net zero ends. So with that, I'd like to draw an end to our discussion, and finally, thank you. Yes.
We have one side participant want to ask a question. Can you give the last opportunity to him?
Of course. Yes, please.
Thank you.
Okay, Professor, it was nice being here in this meeting. This seminar. It was a wonderful presentation, and I'm really impressed. It really shed light on what needs to be done. I think one of the greatest challenges we have here is the industrial transition, because China is industries contribute so much to the carbon emission, and as you rightly mentioned, they are fossil based. So I think one of the greatest challenges is the transition of
could you speak louder?
Transition of the industries from fossil based to technology driven.
Mm-hmm.
I think that would be one of the biggest leap for China. How we can achieve that, I think it will cascade to other sectors. Then number two, I think also the transportation system. As mentioned, with increase in transportation system and more people using EV cars, so the emission from cars will decrease. The only thing is more countries need to embrace maybe railway system, carpooling, so and the use of EV. So I think the biggest change is the aspect of industrial structural changes, industrial transition changes to technology.
So can you be more precise and brief on your questions? So that means Professor.
I think the biggest change will be
Yes. Yeah.
industrial structural changes and transportation structural changes.
So your question is first, what are the kind of necessary changes in the industrial transformation, and the other is on the transport sectors, Professor He.
Okay, thank you. I think first for the industrial, we will have a change to the new, I think still new technology. For example, we need iron and steel for the construction, for the urbanization process, but we have to switch our future technology to actual long-term is a hydrogen based for the air company. That is one point. For the petrol industry, because the transportation pattern will have a big change. I mean, that is not short-term, long-term, in the long-term future, 2014, 2015, or something like that. And in the petrol industry, the major products could not be diesel and gasoline, because the electric car will be majority in the future. So they will switch the final products will switch from the petrol and gasoline and the diesel to rubber. It's not the fuel, the purpose. It's a new material. For example, rubber, or something, or something like that. So, and for the transportation sector, for the passenger car, that is electrification. That's clear, majority electrification. But for diesel truck, could be hydrogen, or even the ammonia hydrogen mixing in the future. But again, I just mentioned almost half of the technology. The direction is clear, but the technology is half of the technology is still on R&D on the way. So, but I think the direction is clear. That is the future, but for the real system, for the larger transportation system, we should increase definitely the real transportation could be important, because it's relatively low emission in terms of the each passenger kilometers and each ton gross kilometers. So but also the real transportation is still rely on electricity. So the electricity demand will be increased in the future, but the supply, the source will be changed a lot. Non-fossil fuel will become the majority. Thank you.
Thanks. I need to draw in on this discussions. And once again, thanks our panelists, Professor He and Mr. Zhang and Mr. Lai, and also Professor Wang, for their valuable sharings and their times, and enlightening us on what's formed come future for us, not only people living in Hong Kong, in China, but I think the rest of the world. Thank you. Thank you all for your times and your interest in listening to this webinars. Thank you.
Thank you.
So this is the end of our TOAF lecture. Thank you for joining us. See you next time. Bye-bye.
Bye-bye. Thank you.
Thank you. Take care.